Welcome to our 16th lecture in Computer Programming 1. We're going to cover one of our final topics. There'll be probably one more after this, which will either be exceptions or analog to digital, or any questions that you have or you'd like me to follow up. Today we're going to talk about iteration and looping. In our last recorded lecture, we talked about if tests. In an if test, we make a decision and we execute a block of logic based on that decision. Loops are very similar. Instead of executing a block once, we execute that block over and over again until a loop condition becomes false. So it's similar to an if test, it's just that we are repeating ourselves over a block of code. This is something that we'll see quite a bit of in programming. An example that I can think of from Plant Places is, let's go to search plants, and I'll say Abies, which is a fir tree. Now, when we get our results, we'll see that we have one row for each fir that was returned. And we see that those furs are, we see that those rows are very similar. It has a common name, a Latin name, and then a size. And then within that, it has pictures. For each fir tree, we see some repeated logic. Make the title bar common, Latin, size, and then make the pictures. Even in the pictures, we see some similarities. They're all about the same size, and they all have hyperlinks where we can click on them and see an expanded view. So within the iteration that is making the row for each tree, there's another iteration that is going out, finding the picture, and presenting the picture. So loops and iterations are very central to computer programming. There are three kinds of loops that we're going to see, and they all do the same thing. It's just a matter of how you wish to do it. There's a while loop and a for loop, and then a do-while loop. So I am looking, so it's kind of off screen here, but if you go to ucjava.com and then Computer Programming 1, and then you can go to the far right menu item, which is iteration. So iteration means repeating something over and over again until a condition becomes false. One of the loops we're going to look at, and by the way, this is one time I miss having an in-person class, because what I typically do when I talk about this and I have a live class is I have three people at a time rather come up, and then we actually walk through an example of a loop, and that one always goes over well. Unfortunately, being online, it's not so easy to do a live example, but needless to say, not to worry, we'll do our best with what we have here. So, a do-while loop. In a do-while loop, we start with the word do. And then just like an if test, we have an open and close curly, and that represents the block of code that should be repeated. Unlike an if test, the test comes at the end, okay? While registered students less than or equal to 24, the test comes at the end. So that means that we're going to execute this block of statements, and then at the end, we're going to test to see if we want to go again. Just like an if test, what's between the parentheses must evaluate to a Boolean, in other words, a true or a false. We can't return a number, we can't return a string. We have to have some comparison that's going to result in a true or a false in a loop. In most loops, we'll have three parts. We'll have a variable that gets declared, and then we'll have something that changes that variable. The declaration isn't here on this line, but we'll see it in a moment. And then a test. So three common things we'll see in every loop. Some kind of variable declaration, something that, and that's what we call the loop control variable, the loop control variable. Something that modifies that loop control variable, and then a test against that loop control variable. Now, if we're missing that middle step, if we're missing the step of modifying the loop control variable, we run into a possible condition where we can have what's called an infinite loop, or a loop that continues to run forever. That basically is what will crash a program, an infinite loop. So we have to be very careful of those. So first we have the do-while loop. Now, Each of the loops is optimized for a different reason, and we're going to look at 3 or 4 different variations of loops, and we're going to use them where they are most optimally used. A do-while loop, since the decision comes at the end, a do-while loop is ideal if you're prompting the user for something and you want to give the user an option to go again. This is a loop you should consider using in programming assignment number 3, where you have to allow the user to enter multiple temperatures. You might want to start with a do and end with a while and say, would you like to enter another temperature? So do-while loops are most frequently used when we're prompting the user for something and we want to give the user a chance to do it again. The while loop is a companion to the do while. Both of these, the while and the do while, we don't know in advance how many times it's going to run because, well, we usually don't. We might, but if it's based on user input, it could run as many times as the user wishes. So let's take a look at a while loop. A while loop is almost identical to a do while. The only difference is there's no word do. There's not a word do in here. And the test comes at the beginning. So it's possible that this test would never evaluate to true. And if that's the case, then the loop body would never execute. With a do-while loop, since the test happens at the end, we know the loop is going to run at least once. And that's the principal difference between a while and a do-while. A do-while is going to run at least once and the test comes at the end. A while loop, the test is at the beginning, so it may run, but if the test never evaluates to true, it might never run. Here again, we have the 3 parts. Initialization. Okay, that should actually be, this is adapted from JavaScript, that should be end. Comparison, and then something that modifies the loop control variable. So that's the 3 parts of a while loop. The other loop that we'll look at is called a for loop. And with a for loop, we usually are iterating over something and we know in advance how many times we're going to iterate. For loops are principally used for things like collections, like arrays and array list. And we'll take a look at one of those today. So a couple more slides here. You can break out of a loop. That's one option. You can use this statement called break. And there we go. There's our break. What break does is if you're in the middle of a loop and you come across a break statement, it will terminate the loop and move to the next line. So that's something that's used sometimes, but I don't see it used very frequently, to be honest with you. There's no need to use that in your programming assignment. Scope is something that's very important, and this gets confusing. Remember what scope is. Scope is when a variable is declared. It is available until the close curly of the loop where it was declared. Here in our for loop, we're declaring a variable called I, and it is only alive within the scope of this loop. Scope is defined as open curly to close curly. So after this loop executes, I is no longer alive. It gets cleaned up out of memory. So be very careful with that. This is where it can get really tricky. With a do-while loop, string input is declared here, and its scope ends in the area I've highlighted in blue. The reason why that's really, really tricky is that the variable goes out of scope here, and this would not compile. If you're not used to that, it might drive you nuts. So the thing to do here is to actually declare string input before the do while, and then you can modify it within the do while. That's perfectly acceptable to do. So I have an example here online, and I also have an exercise you can try if you'd like with the solution. So if you want to try this as some self-study, you're more than welcome to go on to the ucjava.com and try the examples that I have. Meanwhile, I'm going to go back to our friend the driver. And as usual, I'm going to make this very similar to your programming assignment. Honestly, I'm going to go a few steps beyond because I'm going to use some collections that I haven't included in your programming assignment. So my example will be a little bit more advanced, but I will point out as I'm going through this what relates to your programming assignment. Okay, first of all, in driver, we know well, this is just stuff we did before, so we can remove that honestly. We go to prompt user, and then inside of prompt user, we're creating a vehicle. I'm going to clean a couple things up. We no longer need this your vehicle because we're going to find a different way to make more than one vehicle. So I'm going to go through and clean up this class, make it a bit tidier so that we're in a better case and can focus on looping. Okay, and there we go. And remember that I have older versions of this online, so you can always go back to an older version. There we go. We'll clean up the main method, take out any unnecessary statements. Now, here's where a lot of people get stuck on the programming assignment. The directions say allow the user to enter another temperature, which means use a loop. And some people don't know where to put the loop. What you want to put in the loop is what you want to repeat. So if I need to prompt the user for a new vehicle, what do I need there? Well, I need the vehicle variable, and then I need to prompt for miles per gallon, gallons of gas, odometer, and then I, need to call those with the setters. Now, this information down here, we're going to move this to another method. As a matter of fact, I might go ahead and do that now just to clear it up. I will in just a second. But after I do that, what do we want to make the loop body? Pretty much the entire prompt user method. And that's going to be the same for your programming assignment. You probably want to put a do towards the very top, and then you probably want to put the while towards the very bottom. Okay, to clean this up, I am going to take this chunk. This is where we move the vehicle 100 miles. I'm going to move this to another method. Let me show you. It's probably easier than you think. The only trick is it's so easy it'll happen without you even seeing it. So we have to do this in slow motion. I'm going to highlight this area, and again, the blue highlighted area purely has to do with printing the state of the vehicle before, moving the vehicle, and then printing the state of the vehicle afterwards. So I'm going to take this, I'm going to choose refactor and introduce method. What that means is take the highlighted area, put it in its own method, and then call that method where this highlighted area is. So, like I said, it's a little bit tricky. Notice the highlighted area is between 63 and 76. That's going to be moved into a method, and 63 through 76 is going to be replaced with a method call. So I choose introduce method, and I'm going to say move vehicle, and then I'm going to choose OK, and take a look. Now move vehicle is at the end, and we have this new method here called move vehicle, which we'll get to later. Line number 63 now, we're eventually going to move this to another method as well. So what I'm going to do is I'm going to set up my do while. Okay, that first line is just informational, nothing important there. So I'm going to say prompt the user for a series of vehicles. Okay, do open curly. Now, be careful here, because anytime you have an open curly, you have to have one matching closed curly. In other words, for each open curly, there should be a matching closed curly. I'm going to go down to just about the last line. We know we're going to move this line in a moment anyway. Just about the last line, close it and say while. And then I'm going to do an open and close curly here, and we need some test in there. So, what I'm going to do is I need to think about what I want to do for that test. Well, I'm going to want to ask the user, would you like to enter another vehicle? So I'm going to say, let's see, let me put this on a new line. I'm going to say, ask if the user wants to create another vehicle. Okay, string more vehicles equals JOP. Do you want to enter another vehicle? Okay, that'll work. Now I'm going to go down to the while loop and say while more vehicles equals ignore case yes. One trick is we didn't tell the user what to enter here. So we didn't tell the user to enter yes. We could also make a J option pane that has buttons on it. That's probably a better idea. So I'm going to change this message to say type yes if you wish to enter another vehicle. There we go. That looks better. Okay. And you know what? I'm just going to comment out this method call because that's redlining, and we'll fix that later. Now, everything looks good except we have a red line. Why do we have that red line? Remember the slides we just went over. I'm going to mouse over, and we see cannot find symbol. And you might remember we talked about cannot find symbol before. That means we've misspelled something, or we haven't declared something yet, or something is out of scope that we're trying to reference. If I compare more vehicles here, okay, well, they're both spelled the same capitalization, and this is declared before this, but remember, it's a matter of scope. The variable more vehicles is alive only in the blue highlighted area, which means that it goes out of scope and is not alive here. So what I'm going to need to do is I'm going to need to declare this variable in a higher scope. We can't declare a variable more than once, so I need to delete the string here, and I need to declare the variable before the do. Okay, let me line up the comments a bit better. Okay, I'll put a comment here. Declare the loop control variable so that it is in scope for the while test. Okay, there we go. Prompt the user for a series of vehicles. Okay, now we scroll down, and now everything's good. Now, what is the scope of more vehicles now? I'll show you. It's going to be this entire blue area. Remember, a variable is in scope from the point from the point in which it is declared until the close curly of the block where it's declared. So, more vehicles is now in scope for this entire section here. Okay? So, now, one trick is my tabs are off because I have a new block here, and that's very hard to read. I must stress Alt-Shift-F frequently if you're introducing new blocks, and that will automatically tab in all of your lines within a block. It makes it much more readable. Okay, let's see how we're doing now. So I'm going to save, and I'm going to go ahead and run. Okay, how many gallons of gas? 10. How many miles per gallon? 15. How many miles on the odometer? 15,000. Type yes if you wish to enter another vehicle. Note I'm typing yes, and we're going to see each of those prompts again. How many gallons of gas? 20. How many miles per gallon? 20. How many miles on the odometer? 20,000. Yes, and I will go again. So note that it's repeating. Unfortunately, it looks like we have a little UI issue there, but needless to say, note that it is repeating. Let me run that again. Okay, how many gallons of gas? 10, 10, 10,000. Yes. 20, 20, 20,000. Yes. 30, 30, 30,000. This time I'm going to type in no, and the program terminates. So notice that with the DoWhile loop, it is going to repeat everything between the open curly and the closed curly as long as this test evaluates to true, as long as the user is typing the word yes. As soon as the user types the word no, then this test will evaluate to false and the loop will exit. So when you're thinking about where to put your loop, think very carefully about which lines you want to repeat and which lines you do not want to repeat. Okay? So that's a do-while loop. Now let's take a look at a while loop. With a while loop, we put the test up front, so there's a good chance the test might not run. While loops are frequently used in validation because if data is already valid, there's nothing you need to do. So if we look at our prompt user method, we're going to see that we have several places where we are getting an int and then we're setting that int. One of them is miles per gallon and the other is odometer. But we're not doing any range checking. What if somebody entered a negative number for miles per gallon? What if somebody entered a negative number for odometer? Or what if somebody entered miles per gallon of 1,000 and meant to put that in odometer? What we can do in this case is we can validate the data. I'm going to make a new method, and I'm going to say, I'm going to call it private static void, no, sorry, private static int, because I want to return whatever the valid data is. Validate int, excuse me. And then what I'm going to do is I'm going to accept 3 parameter variables. One is a low range, another is a high range, and then the final one is a message. Now, think about method signatures. Why am I doing it this way? Because I want to return whatever valid data we finally get, and then I want to know what's the range between low and high, what's the range between low and high that we want to validate, and then finally, what message do we want to show if the data is too low or too high, okay? So by putting these in as parameter variables, I'm making this a very flexible method, which allows it to be called from different locations. Okay, now I'm getting a red line, but that's because I'm not returning an int yet. So I'll just take care of that first. Declare the return variable, okay? Int valid data equals low minus 1, okay? Or we could just make it minus, let's just make it minus 1. Int valid data equals minus 1, okay? Return valid data. So there we go. Okay, now what I'm going to do is, oh, you know, I'm sorry, I need one more parameter. No, I'm okay. I'm okay. We should be okay with this. What I'm going to do is I'm going to prompt the user for data. Okay, so I'll say JOption pane. And then instead of hard coding a string here, we're just going to put the message in. Whatever. Notice that this message and this message are both yellow. That's because whatever message we have here is what's going to appear here. Okay, we want to save that in a string because it's going to be returned as a string. String input data equals JOption pane show input dialog, and then whatever message is passed to this method. A message like please enter odometer, something like that. Okay. After that, we will parse the response to an int. Okay. So we'll say int input data equals integer dot parse int, because remember that's how we convert a string to an int. Now loop see if we have good data. If not, loop until we do have good data. Okay, now take a look at this. While int input data, actually, you know what? I don't need to redeclare a variable there. Let's just call that valid data. We'll reuse that valid data variable we've already declared. While valid data is greater than or equal to low, and we can use the AND operator here, valid data less than or equal to high, you know what? No, that's wrong. Because that if that's true, that means we do have valid data. I want the opposite. Which there are 2 ways I can do that. I can take this entire expression. This is probably the easiest way. Take the entire expression, surround it with parentheses, and then put an exclamation before that expression. An exclamation takes a true and turns it to false, or takes a false and turns it to true. In real life, that's probably how I would do it. So I'm going to keep that there, but I'm going to do it another way because that might not be very clear if you don't know what the exclamation means. Exclamation is just a negation operator. Takes true and makes it false, takes false and makes it true. What I'm going to do now is I'm going to say if valid data is less than low or if valid data is greater than high. Either one of those conditions means we have invalid data. Either one of those means we have invalid data. So now open curly, close curly, and I'm going to send up a new JOption pane and say the data you entered is out of range. It must be between, and then we'll use the concatenation operator, low, and then another string, and then again the concatenation operator, high. Okay, and then concatenation, and then please, I will do, let's say like a period, please try again, and a period. There we go. Now we'll take this, whatever the user entered, and we'll store it in a new string. String new input data equals JOption pane show input dialog. Okay, valid data equals integer dot parse int new input data. Okay, now let me put some comments here. Prompt the user for valid data. I will see another comment. The data are invalid. By the way, one thing I learned in grad school, data is plural. So it's not the data is invalid, it's the data are invalid. The data are invalid, prompt the user for valid data. Okay. Parse this response to an int and store in the valid data variable. Now, think to yourself, why am I storing this and reassigning valid data here? Because this loop's going to execute again, that's why. And when it executes again, I want to test the latest information that the user has entered. If I were not to reassign valid data, this loop would be infinite. So let's say the range is 0 to 10. User enters 11. 11 is greater than 10. This is going to execute. And it's going to say, please enter better data. Then the user enters 5. We store 5 invalid data. Now, 5 is not less than low, and 5 is not greater than 10. So that will return false, and we're all set. At this point, we're looking in good shape. One thing I will do is add some javadoc comments to this, but aside from that, this method is complete. For javadoc, I do the slash on the question mark key, 2 asterisks, and then enter. And notice what javadoc will do for me. First, I have a line where I say what the method does. Prompt the user and validate that the user entered a number in a valid range. If the user's response is outside of the valid range, prompt again until the user enters valid data. Okay. Now, notice these at symbols, at param. There's one for each parameter variable, and this is a chance for me to say what they should be. So, low, the low end of the range. The data entered must be greater than or equal to this. High, the high end of the range, the data entered must be less than or equal to this. Message, the message to show the user when prompting for data, and then return the last inputted data. There we go. Okay, I'll save. And now I'm going to scroll up, and where we have int mpg in this prompt, I'm going to consolidate these two. I'm going to make it one line, and I'm going to call the validate int method that we just made. So here we go. First, validate int, okay, and I need to put in a message. I'll just copy and paste this message. Okay, how many miles per gallon? Okay, now I can do away with this line. I need to also pass a low and a high range. Well, it can't be less than 0. Realistically, it probably shouldn't be more than about 100. Okay? And I need to take this and I need to assign it to an int variable, which is where I steal from this other line we'll be getting rid of. Boom, there we go. And finally, I can do a little housekeeping here. Why doesn't it like this? Oh, missing a semicolon. Okay, there we go. So I've replaced those two lines with this one line, okay? Validate the, let's say, prompt and validate data for MPG. So I took the two lines of prompting for the data, converting to an int, and I've now called this validate int method. That was pretty fun. Let's do it again for odometer. Again, I'm going to consolidate these two lines with one call to validate int. So we'll steal things one part at a time. First, the assignment variable, int odometer, because remember, validate int is going to return a validated number. Int odometer equals validate int. Okay, odometer can't be less than 0. Realistically, probably about 1 million is a high number. And we want to be reasonable. And then the message, how many miles on the odometer? Okay, and terminate with a semicolon. And then I'll come down here and clean up the lines I no longer need. So there we go. Okay, let's do a quick gut check here. Well, let me put a comment here. Okay, prompt for and validate the range of the odometer. Okay, I will save. And now I'm going to go ahead and I'll do a quick run, and if all works well, then we'll debug. So I run. How many gallons of gas? We didn't validate this one, so we'll go ahead and say 12. How many miles per gallon? Let me put -4. The data you entered are out, see, that should be are out of range. It must be between 0 and 100. Please try again. I enter 101, we get the prompt again. 120, get the prompt again. Now, if I enter 24, all set. So notice that the while loop continues to execute until that condition becomes false. Okay. Now, how many miles on the odometer? Once again, -1. The data is out of range. Please choose between 0 and 1 million. So I'll do 1 million and 1. The data is out of range. Okay, so I'll do 140,000. And there we go. And we're all set. I'll type no, and there we go. So let's watch this happen in the debugger. Now that we've seen it run live, I'm going to choose debug. Okay. And I'll choose F8. F8. How many gallons of gas? We've seen this guy before. So we'll say 20. Okay. We didn't change any of that. Now, I've been pressing F8 to advance the debugger. As we get into writing methods, we're going to find that F7 is our best friend. F7 means step into, means walk into and execute this method. Okay, so if I'm on a method call, if I choose F8, it will run that method without any interaction from me and then move to the next line. If I choose F7, it's going to take me into that method and allow me to see it. So at this point, I'm going to choose the step into key, which is F7. And here we go. Okay, so we show the prompt, how many miles per gallon? I put -1. Parse to an int. Is it less than 0 or is it greater than 100? It is less than 0, so the while loop is going to return true. Prompt again. Okay, we'll put 120. Okay, now notice we're going to go back up to the test again. And remember, the 120 is now invalid data. As a matter of fact, if I mouse over valid data, I will see the value 120. If I mouse over low, we'll see 0. If I mouse over high, we'll see 100. So see, is 120 greater than 100? Yes, it is. And we have an OR here. So if either one of these is true, the entire expression is true. So I choose F8. Okay, the data you've entered is out of range. Okay, sure, we'll put in 12, which is in range. And now we're going to F8. Now it's going to run the test again. But notice valid data is 12, which is greater than 0. Valid data is 12, which is less than high. Both of these now return false. So that the loop will not execute again. We go to the return line, and then we go back up to where the method was initially called. Okay? For odometer, I could choose F7 and we could walk through that again, or if I choose F8, it will just go ahead and execute and then move to line 58. That method will execute. So I choose F8. How many miles on the odometer? We'll go ahead and put in a valid number. F8, F8. Type yes if you wish to enter another vehicle. I'll type yes. Now, I did equals ignore case, so more vehicles is yes. And we're comparing it to the constant yes. Okay, so we're going to loop again. So I choose F8. This time we'll go a little bit faster. How many gallons of gas? We'll say, we'll make this one 13. Okay, I'm not going to step into the methods this time. How many miles per gallon? 14. How many miles are on the odometer? 14,000. And this time I'm going to say no. Now notice more vehicles has a value of no. No is not equal to yes. Thus, this is going to return false, and the loop will stop executing, and we're all set. So that is a for loop. I'm sorry, that is a do while loop and a while loop. Next, we're going to take a look at for loops and arrays. We're at the 37-minute mark, which is where I start to get a little bit nervous. So I'm going to go ahead and save this recording and upload it, and then start a new recording. Thank you.